Hello everyone, welcome back to my video. So today I am going to share an useful information about a small language model called SMOL Small LM2. So this particular model is considered to be a small language model. So today I am going to show how this model works and I'm going to deploy this model on a fast API server and host it on a Docker container. I'm also going to create another web application which will capture the input prompt from the user and send the prompt to the fast API server where the model is hosted. The model taking the text prompt, it is going to do the text generation based on the prompt, and then the generated text is again going to be sent back to the application, the client application, and the generated text will be displayed on the web application. So there is going to be two different Docker application which is going to interact based on the user prompt and then the generated text from the model. So the video is going to be interesting, so please do not skip and watch it till the end. So getting into what a small LM2 model. So small LM2 model, as I told, it is a small language model. It consists of about 135 million parameters. So here is a PyTorch implementation of the small LM2 model. So basically it is having a embedding layer with the positional encoding and then the tokens. Then we have the decoder layer, the hidden layers basically, and the RMS normalization layer, and then we follow the rotational embedding rotational position embedding for this model. So this model, it consists of about 30 transformers layers. So basically this is the the architecture of the small language model. So we have the embedding layer, and then the decoder layer, RMS normalization layer, and then the rotational position embedding layer. So each of these layers are further expanded. Like we are having attention layer here. We have the multi-layer perceptron layer again here. We have the RMS norm, and then we call the positional embedding in this particular layers for each decoder layer. And we do have this attention weights and other calculations performed. So this is the architecture of the small LM2 transformer model. And then we have a main application file that is going to create this particular small LM2 model. So it is going to have about 30 hidden layers. So basically we'll be having a 30 layers in the transformer, and then we have 576 hidden layers, and then nine attention multi-head attention layers, and then three key value heads. So we have this query key value. So in this we are going to have three key value heads. Again, there is going to be around 49,150 vocabulary size. So as I told earlier, we are going to use this rope embedding, that is the rotational position embedding. We are going to have a silu activation function, and then we are going to have as a RMS norm as a normalization layer. So this is about the small, the language model. So it is trained on the Cosmic 2 Cosmopedia version 2 dataset, and the tokenizer I'm going to use is also Cosmos 2 tokenizer. So so what I do now is like I create a fast API function wherein the model is loaded from the model is already pre-trained and the weights are loaded from local directory. So I have saved it as a checkpoint. So I'll be loading the model from the pre-trained model from that particular path, and then based on this configuration value, the model weights are going to be assigned. And then I have a the post API where whatever the whenever I get a request with the text prompt, the text prompt is going to be tokenized, and then the tokenized text is going to be sent into this small model, and the generated text is again going to be decoded. Once the decoded text are again going to be appended to a list and then joined into a complete sentence. The generated sentence is going to be sent back to the calling client application. So this is the fast API class that is going to make use of the small LM2 model, and then whatever the text prompt is going to be submitted to this particular model, it is going to complete the sentence and then give it back to the calling application. So I right now have a Docker file here. So I'm loading a Python 3.9 base model base image. I create a working directory called app, and then I'm going to move my model file, my main app file, then the requirement.txt, the required libraries to be installed, then my tokenizer, and then my pre-trained saved model to the app directory. I'm also going to install whatever the libraries present in the requirement.txt. I'm going to expose the port number 8001 for communicating, and then I'm going to call the fast API fast API library on my main class on my app method. So it is going to start from here, and then I'm going to host it on the local host on the port 8001. So this is going to be running as a server application on one of the Docker container. So this particular app folder is called as a small LM2 server. And next, let me go to the text generation app. So here I have an HTML page. So that has got a small multi-line text box where the user can enter a prompt, and he has a text box to specify the number of the sequence length. So how many words a sentence should be for generation, and next, the number of sequences it has to generate. Like when you specify it as a one, it will generate only one specific sequence. In case we want multiple sequence, you can increase this particular value. So these are the user interface to capture the value, and it has a text box to display the generated text. It is a pretty simple HTML user interface. So let me go to the app file. So this app file is again a fast API app where we load that particular, the index .html from the template folder using a Jinja template, and then during the get response we try to load the index .html as a home page. Once the user enters a text prompt and click on the submit button, the generate text API would be called on the on the post method. So we capture the prompt, the length, the number of sequence, and then we pass that particular information to the the server, the app, the small LM2 server that is running on 8001 port, and we call the generate method of the fast API there. So what happens is, like, in this generate method, it receives the text prompt, and it is going to be, as I told, tokenized, and the tokens are going to be sent to the model. The model is going to generate based on number of the input sequences, and then the number of length. So how many tokens it has to generate, and then generated tokens are going to be decoded again, and then the texts are again going to be joined and formed as a sentences. So once this server returns the generated sentence, the client application is going to receive it in the response, and then it is going to load it on the the separate user interface and show us what is the text generated by the model. So here again in the Docker file, I'm making use of the same Python 3.9 slim image. I create a working directory as app. I copy the main py, then the requirement.txt, and also the UI, my web HTML page from the template folder to the app template folder. So the next step is to install all the libraries present in the requirement.txt, and then I'm exposing a port 8000, and then I'm going to launch a fast API server. Again, as shown, the main from the main class, the app method is going to run, and then I'm hosting on the local host on the port 8080. So now to come to bridge this, we have a Docker Compose file where we specify the services as the app1. So app1 is nothing but the small LM2 server. So it is being exposed on 8001 port, and I'm going to add a app network for that. Similarly, for the app2, it is a text generator app. it is going to be running on 8000 port number, and then we have a app network connecting, bridging these two particular applications. Like these are this acts as a bridge between these two applications. So this is the Docker file. So let's build this Docker image. So the Docker image is getting built. Yeah, the Docker is started. So let's check. So we can see both the applications are started here. So let me open the browser. So I will go to HTTP localhost 8001. So that is where my server is running. Yeah, we can see the server is running here. So I'll open my client application, HTTP localhost 8000. Yeah, so you can see the user interface here, wherein it is asking us to enter the text prompt. So I will enter here once upon a time. So now I want 50 words in my sequence, and I want one sequence. So I will ask my model to generate a text using once upon a time. So when I click on generate text, the model is taking the prompt and it is trying to generate. So you see, once upon a time range before compact seren, it is trying to generate certain words. So since the model is trained locally by me, it is not trained completely with a reduced number of losses. So it is just an illustration. Yeah, I hope you understand like how this works. So let me enter another word, and I'll ask it to generate two sequence. How are So let's see if it is able to generate two sequence with how are you doing, brother? So you see it is trying to give two sequences. And with how are you doing, brother? Political climate assured celebration for boring clearance. So it is trying to generate something, but it is not meaningful one. But I hope you get it. Like when we try to train a small language model with in a robust data set, I hope the generated text also will be in a better way. We have to generate a good reduce the loss during the training in a good amount so that the model generates in a more meaningful way. So yeah, this is about the hosting a small language model on a Docker and creating a client application to interact with the small language model. I hope you like the video. Please leave your comments in the comment section. Thank you so much.